And we're back with one of the stars of the Day of Giving show every year, Dr. Eric Bubar from the engineering program. So we've already talked to you the last 2 years, about the basics of the program. So now tell us, how's the program developing and expanding now that you've had a few classes through the door? Is anyone close to graduating from the engineering program yet?
We're doing a great job so far. So we have one superstar student that's probably ready to graduate next year, so a full year early from our biomedical program. We started off with 12 students last year, and this year's freshman class is about 22, so we've almost doubled. So we have some nice growth. And we are recruiting a lot of diverse students. So usually engineering programs tend to be male-dominated. Ours is woman-dominated. So we have about, I think it's about 50% females, women in our classes. And usually that's about 20%, so it's very female-friendly too.
Actually, that was going to be one of my next questions. I think we're seeing in athletics now, we're getting some, female student athlete prospective recruits in STEM that maybe aren't finding these opportunities, in other areas. How much is DC playing a role in that, being in this area and the connections we have?
I think that's helping a lot, and it's helping with. I think actually athletics is a huge help for us in recruiting these young women that want to go into STEM, and they come to Marymount and they see it's not an intimidating, super male-dominated, macho kind of atmosphere. Our engineering program is very, very service-oriented, and very friendly, and very welcoming, and we don't have any kind of toxic atmosphere that you see in some engineering programs might have.
And this is Day of Giving. If a larger donor wanted to support the engineering program, what are some of the ideas you would pitch?
So there's some great things that we can do. One of the big ones that I do in my lab is prosthetic limbs. So here you can see there's a prosthetic arm. This is actually my arm, and this is designed. We can make this for somebody for about between $20 and $50, full-on prosthetic that they can use. And then we can take this and we can actually put machines, put electronics inside of it, and let somebody control it with either their muscles, or we have a neuroscience student that engineering students are partnering with to let you control it with your thoughts. So you can think about it, what you want it to do, and it will do it. We're doing all sorts of cool projects too. So a lot of orthotics and prosthetics. This right here, this giant thing, this is the starts to an orthotic brace for a sea lion that has arthritis. So we can print orthotics for sea lions. We are starting to explore legs. So lower limb prosthetics, we can do those. And we really need to study these very closely, because with the leg, you don't want it to break when it's subjected to the weight of somebody standing on it. So there we can see this one broke in our testing. So we're making sure that we're doing this properly and making sure that things are safe. So if they want to invest, we can buy nicer 3D printers, bigger 3D printers, industrial grade ones to actually print stronger items. We have started exploring how we can 3D print houses. And we actually have a small scale printer that will print with clay, which is the same exact technology that goes into homes. I'll toss the number out there. With $100,000, we could buy a house 3D printer. And then about $50,000 more than that, $150,000, we can start 3D printing houses for anybody that needs them.
No. Explain that 3D printing technology a little more, how it works, what materials go into it, maybe what the costs are of those materials. I'll be honest, I don't understand
Absolutely. Absolutely. So let me grab one more little guy in here. So this is the newest project that we're working on. We're working on prosthetics for partial limb differences. So this is an individual that we took a 3D scan, and he's missing 3 of his fingers, you can see. And if you look very, very closely at this, probably can't see on camera, but you can see there's different layers. So 3D printing, the way it works is you lay down a layer of plastic, and then the printer goes up and puts a layer on top of that, and then on top of that, on top of that. So it just builds something up layer by layer. And more or less, most of the 3D printers we have work with that process. So a house 3D printer does the same thing. It just prints a layer on top of another layer on top of another one. And the only thing that really changes is the material you use. So with this, we're 3D printing with basically, this is a flexible kind of plastic, so it's squishy. It's like a Lego tire kind of plastic. And it comes in like a little spaghetti shape. And you basically feed it into what's more or less a hot glue gun, and it melts the plastic so it can make up your layer. Same thing here. So this is partial prosthetic. this is what we're designing. We're designing just a finger that can attach onto somebody's residual kind of finger that they have left. And this is printed basically, again, out of kind of Lego brick that's turned into a little spaghetti shape, and it feeds into a very hot part that melts it and lays down a layer and builds up your 3D print.
How long would it take to print something of this size?
So this hand itself takes about, this one took about 5 hours to actually 3D print this. Fingers are pretty quick. They take about maybe an hour. And the costs of the material, actually to print everything that I've shown you today, probably about one spool of plastic. The plastic comes on spools, and that's about $20. Wow. So it's very cost effective. Same thing with house 3D printers. The material is going to be more expensive because it's cement, but a fraction of what you'd pay to get the raw materials.
Has the time taken to print, is that getting faster and faster as this technology develops?
Time is getting a lot faster. When we first started our printers, something like this would take about 40 hours to print, and now it's down to, 5 or 10? And then we have some new printers in the lab that cut that time down even more. And the house 3D printers, those actually go really quick. We've built up towers that are about 6 inches tall. Those can be done in about 40 minutes, so super, super fast. And then we have an exciting thing coming for all the chefs out there. We have a chocolate 3D printer. So we'll be able to 3D print things in chocolate. We'll just be printing candy. And those will go really quick.
Yeah. Anything else you brought to show us? Have we?
I can show you one more really neat thing. This is kind of neat. So we like to encourage our students to have fun, and one of the ways we have fun, we mimic superhero, try to recreate superhero technologies. So this is a full-on superhero helmet. You can actually wear this. If you want to hold that very quickly. It's actually got magnets built into it, so the back can actually pop off, so I could actually get this onto my head.
You should have done the whole interview wearing that.
I should. And the eyes will actually pop off, so you can, why not? We'll go for it.
Yes.
So I got to lose the glasses. So what we do with this, we have fun, but we also get really, really good at sizing. So sizing is very hard in prosthetics and orthotics. You need a really, really good tight fit. So this has been sized very precisely using 3D scanning to my head. So it's going to look like it doesn't fit, but it fits perfectly. So if we can... Just not too big, not too small. Now I'm Spider-Man. And I can still get it off. So there you go.
All right, well, Spider-Man, thank you for joining us,
my pleasure.
As always, to show us all the cool things going on. Always a highlight.
And thank you for letting me speak. Yeah. And thanks for the time.